everyone and welcome back to Pharmaceutical Concepts by Dr. Ojasvi Gadge. Myself, I am Vora, and I will be giving a small briefing about the difference between normal, binomial and Poisson's distribution, which is included in your B Pharmacy Semester 8 Biostatistics and Research Methodology as per the PCI syllabus. So firstly, speaking about the distribution in the statistics. So distribution in statistics is of two types. One is frequency distribution and other is probability distribution. So frequency is basically the number of times any particular item or the anything is being portrayed. In either frequency distribution can be in the form of tables or it can be in the form of charts. Similarly, probability distribution is further of three types: normal, binomial and Poisson's. So today we are going to discuss the difference between these three distributions and which distribution is to be applied at which conditions. So firstly, here we can say that the distribution of normal type. Let's have a differentiating view. So firstly, there is normal, then there is binomial, and then there is Poisson's. So in normal distribution, there is a Gaussian curve which is formed. Gaussian curve. Now, what is this Gaussian curve? It is basically a bell-shaped curve. It is basically a bell-shaped curve like this. So this is a Gaussian curve in which there is a bell shape. The binomial curve, the binomial distribution is very famous as Bernoulli's distribution. So in the exam, the question could be asked as give the example of binomial or Bernoulli's distribution, or write a short note on Bernoulli's distribution. Poisson as such doesn't have a synonymous name. The next step is normal distribution is always used for continuous data. It is always used for continuous data, while your binomial and Poisson both are used for discrete data. Now, what do you mean by discrete data and what do you mean by continuous data? So when you have a particular class interval given or a particular range given, like suppose 10 to 20, 20 to 30. So this is a continuous, and in the frequency of 10 to 20 is suppose 2, of 10 to 20 is suppose 3. So this is a kind of a continuous distribution. Discrete means randomly the numbers are given 2, 3, 5, 8 like this. So this is called as discrete data or raw data. Now in continuous also there are two types of data that can be continuous. One is exclusive continuous data and one is inclusive continuous data. Now what is exclusive and inclusive? In exclusive, the class interval is continuously, the lower limit of one class is same as the upper limit of the other class. So here you can see 10 to 20, 20 to 30, 30 to 40. So the lower limit, that is the the lower limit, that is 20, and upper limit of this class is 20. So both are same, there is no difference. But here in inclusive, if you see, if it's 10 to 19, then it will be 20 to 29, 30 to 39. So here you can see the data is not the lower limit of the upper class is not the same as the upper limit of this class. Here it is 19, here it is 20. So this is the major types of continuous data that you need to know about the distribution. Now the next thing that is very important is the phenomenon of mean, median and mode, which is also called as central tendency. So in normal distribution curve, mean is equal to median is equal to mode. So mean, median, mode all are equal. In binomial, mean is slightly greater than the variance. Mean is slightly greater than the variance. And in Poisson, mean is equal to variance. So this is very important point that you need to know. So here the standard deviation would be the square root of variance or the square root of mean. And this question had appeared in the year 2023 Biostatistics and Research Methodology. The question was, if the mean in a Poisson's distribution is 5.1, what will be its standard deviation? Now the four options were minus 5.1, plus 5.1, 1 upon 5.1, and square root of 5.1. In the comment section, write down the correct answer. Is it A, B, C, or D? The mean is 5.1. You have to find out the standard deviation. So this is a small differentiation amongst mean, median, mode, variance, and the standard deviation between the three different distribution curves. In normal distribution, the area under curve AUC is 1, and the value of standard deviation is also 1. So this is very important. Now in binomial, you need to remember one ratio. What is that ratio? That ratio is the ratio of quartile deviation, which is QD, is to mean deviation, which is MD, is to standard deviation. What is this ratio? This ratio is 10 is to 12 is to 15. 10 is to 12 is to 15. So this is a very important ratio of quartile deviation. And in normal distribution, you have a ratio of you have a relationship between mode, median, and mean. Mode is equal to 3 median minus 2 mean. Usually when we give a relationship of any central tendency, this is the equation. Mode is equal to 3 median minus 2 mean. 3 median minus 2 mean. So this is the relationship between central tendency. And when you speak about the relationship between dispersion, so this is a relationship between dispersion. So one dispersion is quartile, one dispersion is mean deviation, and other dispersion is standard deviation. So just jot down this relationship between all of these. Now, in normal distribution, there are two phenomena, skewness and kurtosis. These both are absent. Skewness and kurtosis. It's basically change in the shape of a peak. Change in the shape of a peak. So if your curve is like this, it has to be like this. It won't be skewed positively like this or skewed negatively like this. So the skewness is there is no skewness or kurtosis in normal distribution, but in binomial distribution there is skewness and kurtosis. It is based upon the p-value. This p-value is number of successes. We will discuss it in ahead. And in Poisson's distribution, the skewness is again not very much seen. Not very much seen. Okay, so this is one of the difference. And one important thing, in binomial distribution, the name itself says binomial, means one of the two. So the all the events are fixed. The events are fixed, and there are independent variables. Independent. Now, how do we understand this? So suppose if there is a case, you have a coin and that coin is tossed. So either there can be heads or there can be tail. There cannot be heads and tails both as the outcome. So when there is only one possible outcome, we call it independent variables and fixed events. And this data is called as dichotomous data. What is this data called as? When there is only one possible outcome, like suppose if you are rolling a dice, so either it can be 1, 2, 3, 4, 5, or 6. One of the 6 can appear. So the probability becomes 1 by 6. So that is this data is called as dichotomous data. Now let's quickly see this on a particular slide, the difference between the three. So the first point here says that the normal distribution is also called as the Gaussian distribution curve or the bell-shaped distribution curve. The binomial is called as the Bernoulli's distribution curve, and Poisson doesn't have a synonymous name. In normal distribution curve, the mean, median, and mode, all of them are equal. In binomial, mean is slightly greater than the variance, and in Poisson, mean is equal to variance. In formula, though there is different formula for normal distribution. So here I am writing the formula. It is very important to write the formula when you are writing a short note. So y is equal to 1 upon square root of 2 pi into sigma e raised to minus x minus u the whole square, x minus mu the whole square upon 2 sigma square. Okay, so what is this data now? This is E ka value is approximately around 2.71. Okay, the sigma is the standard deviation and the mu is the mean. Mu is the mean and sigma is the standard deviation. Pi की value we all are familiar, 3.14, and E is around 2.718. So this is the formula for normal distribution curve. Now speaking about the binomial distribution curve, I said the data is dichomatous data. See over here. So it can be the P plus Q, number of successes and number of failures is equal to 1. P is the number of successes, Q is the number of failures, and the mean will be NP, number of possible events into number of successes, variance and standard deviation. So the standard deviation will be NPQ, number of mean. So you can say standard deviation is equal to mean into Q, that is NP into Q. So this NP, P is the probability of successful events and Q is the number of failures. And variance will be the only NPQ. In standard deviation, there is square root of NPQ. There is square root of NPQ here. And variance will only be NPQ. We will remove the square root because we know the relationship between standard deviation and variance. Standard deviation is equal to square of variance. So this is important formula for binomial distribution. Now speaking about one important formula where you actually come to know about the combinations and probability, that is NCR P raised to R Q raised to N minus R. Now this C can be further simplified as N factorial upon R factorial into N minus R factorial. In the upcoming videos, we will be learning how to solve these numericals. But right now, just jot down this formula. NCR P raised to R Q raised to N minus R. Now this can be further written as N factorial upon R factorial into N minus R factorial. Okay. So this is very, very important formula. And N is the number of trials that you're attempting, or number of samples, and R is the R is the number of successes which are desired, and P is obviously probability of successes, Q is probability of failure. So this is the formula for binomial distribution. In Poisson's distribution, the formula is e raised to minus lambda raised to x upon x factorial. So this is very, again, like binomial distribution. This is a particular formula for Poisson's distribution. E raised to minus lambda raised to x upon x factorial. Okay, where lambda is the mean. And x can be whatever they have asked for in the question, 0, 1, 2, 3, depends upon the question what are they asking. If it is at the most, at least. So whenever you're solving probability and binomials numericals, these two words are to be kept in mind, at the most and at least. So do not uh, forget these two important words when you're solving numericals. Okay, the next point is, or area under curve and standard deviation is 1 for normal distribution. The ratio of QD, MD, standard deviation is around this 10 is to 12 is to 15, and Poisson's is uniparametric in nature. Now the next point is, there is no skewness, which is C. In binomial distribution, there is skewness. So if P is less than 0.5, there is positive skewness. If P is greater than 0.5, there is negative skewness. P is less than 5, so positive skewness. P is greater than 5, so negative skewness. Okay. And Poisson's distribution is only applicable if the n is infinity. The value of n is infinity and P tends to 0. So number of successes tends to 0 and number of trials is infinity. There are infinite number of trials. Now the curve, in normal there is symmetrical and bell-shaped curve, and in binomial the events are fixed and the variables are independent. The data used in normal is continuous, while in binomial and Poisson it is discrete. Binomial, the data is also called as dichomatous data, and there is presence of mutually exclusive or exhaustive events. What is this mutually exhaustive or exclusive events? There is, again, the example of coin. It can be either heads or tails. So they are mutually exhaustive events. Only one of them is the possible outcome. So that's all for today. I hope you did enjoy this session and learned a lot. Do subscribe to Pharmaceutical Concepts by Dr. Ojasvi Garge. and do follow us for more such interesting videos on biostatistics. Thank you so much.